All right, let's go ahead and take a look at this quotient rule. So before this, we had talked about the sum and difference rules, in which case we could just go ahead and take the derivatives of the sums, and it's the sum of the derivatives and that sort of thing. And then we looked at the product rule, which was a little different. Okay, so now the quotient rule is going to look similar to the product rule. It is going to have some subtle differences, though. Products are associated with additions, and divisions are typically associated with subtractions, and therefore we have a subtraction in the middle now instead of an addition sign. And this factor of g squared underneath. Other than that, though, it's pretty similar. And so when we talk about this, it's going to have kind of the same conditions with one caveat. If f and g are differentiable functions, meaning individual derivatives exist, and g of x is not 0, okay, because we can't divide by 0, so g of x can't be 0, then the derivative of the quotient of the two, or f divided by g, order matters here, be very careful. The derivative of the top divided by the bottom is equal to the derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. Okay, this is a little bit more complicated, but not much. The important thing here is it counts as far as what you have where. And so I typically will always call f the top and g the bottom. And so that way I can memorize it, and that's all there is to it. Your book goes through a nice little proof of it, so I'm not going to go through and prove each and every one of these theorems. Okay, so let's go try it out. So we have this function, h of x, and it's equal to x over x squared plus 1. And now, since this is my second time doing this, I'm going to remember this. First things first, I identify what the two functions are. F is the top, so f of x is x, and its derivative, just like in the product rule, its derivative is 1. The bottom is g of x, and that is x squared plus 1, and its derivative is 2x. So now I'm going to take all of those things and I'm going to put it into our equation here. So h prime of x is equal to the derivative of the top times the bottom. I recommend you writing this down each and every time, minus the derivative of the bottom times the top, all over the bottom squared. That way you memorize it. All right, continuing on. I had a little small interruption. Over the bottom squared. And as I was saying before, I really would encourage you to write this down each and every time until you get it down cold, so that you're not making any mistakes in the formula. That way you can concentrate on the derivatives. So the derivative of f, in this case, let's switch colors here. The derivative of f is 1. G is x squared plus 1, minus the derivative of g, which is 2x, times f, which is x, all over the bottom over g squared. Okay. Now, most people would probably take a look at this bottom and immediately expand it into x to the fourth plus 2x squared plus 1. Don't do that yet. Wait on this, because right now it's in a semi-simplified form. We might be able to cancel stuff out. All right, so I would hold off ever doing that until it was absolutely necessary. So let's go ahead and work on the top here. 1 times, and distributing our 1, we have x squared plus 1 minus 2x times x is 2x squared over x squared plus 1 quantity squared. And so that gives us a negative x squared plus 1 all over x squared plus 1 quantity squared. So one of the techniques that I use here is I start rewriting it to try to make it look like the bottom. And unfortunately, only one of the signs differs. And so there's no way that we can make it look like the bottom. And unfortunately then, yeah, we're kind of going to be done. There are ways to factor the bottom, but I don't think that's going to be any particular help in this case. And so I would leave that as my answer. An alternate way to do that is you can put the subtraction after the 1, and so it's 1 minus x squared all over x squared plus 1 quantity squared. I don't see any particular reason to kind of beat a dead horse as far as factoring here. So I'm just going to kind of leave it as it is. All right, let's take a look at a second one here. Get a little bit more difficult. Let's take a look at cosine of t over t cubed. Okay, so we're going to try a different one. So we're going to identify h of x as cosine of t. Oh, I said cosine of t and then I put x. Our variable is t. We have a different variable this time. Cosine of t over t cubed. All right, so let's go ahead and identify, very first thing, identify the top as f. F of x is equal to cosine. Come on now, wake up. F of t is the cosine of t. That means that f prime of t is equal to negative sine of t. These are the two trig functions that I encourage my students to remember. The rest of them you can derive, and so I don't really actively encourage just rote memorization. It's not good for understanding to encourage rote memorization in my book. And so I want you to understand where it comes from, not why it's there, and why it's there, not that it is. The bottom, g of t, is equal to t cubed. And so its derivative is equal to 3t squared. And that comes from the power rule. So what we can do is we can just go ahead and put this right into our thought process here. We have h prime of t is equal to the derivative of the top, which is f prime of t, times the bottom, which is g of t, minus the derivative of the bottom, or g prime of t, times the top, f of t, all over the bottom, g of t, squared. All right, so substituting in our values, we have the derivative of f of t is negative sine t times g of t, which is t cubed, minus g prime of t, which is 3t squared, times f of t, which is cosine of t, all over g of t squared, which is t cubed squared. All right, now we all remember our exponent rules, and so if we combine the top, we are going to have a negative t cubed. I always try to put the trig functions after the polynomials. T cubed sine of t minus 3t squared cosine of t, all divided by t to the 6. And now if you look, we have a t cubed and a t squared on the top. We have a t to the 6 on the bottom. We can go ahead and factor this out and cancel out 2 of the powers of t. So when we do that, we're going to cancel 2 of the powers because there's a commonality of t squared. So we can bring that out. Negative t sine t minus 3 cosine t all over t squared t to the 4th. So I'm factoring out a t squared both top and bottom. That means these go away. And I am left with negative t sine t minus 3 cosine t all over t to the 4th. You could, I suppose, if you wanted to call it a slightly different form here, which would be to eliminate the t's on top in all places, negative sine of t over t cubed minus 3 cosine of t over t to the 4th. I just don't particularly see any advantage in doing that. I think it adds to the number of strokes on your calculator, so I'm not going to worry about it. All right, so two examples of the quotient rule. It can be very easy, but remember, write it down each and every time you do it until you have it cold.